Assalamualaikum and hello everyone. Welcome to the video for 7.2 acid-base titration. In this video, we're going to be discussing past year questions regarding the titration. On your notes will be on page 22. Okay, for PSPM 2018 and 19, okay, the question is, a sample of 0.24 gram of unknown monoprotic acid was dissolved in 25 ml of water and titrated with 0.1 molar now. Our sodium hydroxide. The acid required 27.4 ml of the base to reach equivalent point. So what does it mean is, in our conical flask, we have our acid here, our unknown acid. Okay, and then it will be titrated with our sodium hydroxide. Okay, to reach equivalent point, we have 27.4 ml of the base itself. But then again, what I would like to draw, so I'm going to draw the conical flask, and then I'm going to write down the information regarding the acid and the base. Okay, so this is the conical flask, and then we have our acid formation here and our base. Okay, next question is to determine the molarity of the acid. Okay, so how to know the molarity of acid? Okay, again, molarity is actually, to find out molarity, molarity is mole divided by volume, which must be in liter. Okay, but then again, for the mole, okay, mole we can find it out using mass divided by molar mass. Okay, we have our mass, but then how to determine the molar mass? Okay, because what we have here is HA. H ni is our hydrogen, A ni is our unknown lah. Unknown macam kita ni HX. Sama lah, X tu is actually our unknown. So we can't find the mole using mass divided by molar mass. Okay, how we going to find out? We're going to find out through an equation, the mole. Okay, so macam mana tu? Okay, now let's look here. Okay, so now let's do the equation for our acid and base. I'm just going to zoom in. Okay, so our acid and base, remember that for the equation, we have to write down the state, whether it's gas, liquid, solid, or aqueous. Where the liquid is specifically only for H2O. Any of the solution in chapter 7, we're going to use aqueous. So again, I'm going to write down the equation. So for the reaction of acid and base, we're going to form salt and water. Okay, where usually our acid will dissociate the hydrogen and the base will dissociate its base. So here, these two will dissociate to form H2O liquid, and what we have left is actually NaA. What we have, our sodium, Na, and then from our acid, what we have left is actually A, this A. So the NaA. Okay, so the state will be aqueous as well. Aqueous plus H2O liquid. Okay, so this will be the equation. Okay, the question asks for the molarity of HA here. Okay, but then we're going to find out the mole. How are we going to find out the mole of HA? Okay, as we can see, 1 mole of our acid equivalent to 1 mole of our sodium hydroxide. Oh, this one, sorry. For sodium hydroxide, we have 27.4 ml to reach equivalent. The concentration here is 0.1 molar now. Just going to include here 0.1 molar sodium hydroxide. Okay. So actually, I'm just going to write down 1 mole HA equivalent to 1 mole NaOH. And then we're going to find out the mole. How are we going to find out the mole? If we can't use mass over molar mass, the other way is we're going to find out N equal to mV over 1000. M stands for molarity, V stands for volume. It's divided by 1000 because the volume must be in ml. Okay, so I'm just going to write the formula. Okay, don't forget to substitute the value here. And then for the mole of now, we will get 2.74 exponent negative 3 mole. Okay, since the mole of now, 1 mole of now is equivalent to 1 mole of acid. So the number of mole of HA will become the same value lah, 2.74 exponent negative 3 mole. Okay. So here we got the molarity. This one. How about the volume? Okay, for the volume of acid itself, from the question, kat sini dia bagi tahu 0.214 gram is dissolved in 25 ml of water. So, bila kita dissolvekan kita punya solid dalam kita punya 25 ml of solution, adakah kita punya solution tu akan bertambah? Dia tidak lah. Volume dia masih sama lagi lah. Okay, masih lagi sama. It's just that kita tambahkan solid saja dalam tu. So, volume dalam kes ni is 25 ml. But then again, for molarity, we want it to be in liter. So, 0.025 liter. So, we're just going to substitute this value into this formula. Okay, so, the molarity will be 0.1096 molar. Okay, so that is for question number 1. Determine the molarity. Okay, for this chapter 7.2, usually we're going to find out the mole using N equal to mv over 1000. This one you have to be very familiar lah. And then to find out the mole, we're going to compare 1 mole, 1 mole. Back to our chapter 1. Okay, so now we know that the concentration, okay, I'm just going to write down sini lah. Just going to did it here. So we know that concentration here 0.1096 molar. And then the volume that we have is 25 mil. Okay. So this will be the value or the information regarding this. Okay. So question number 2. Calculate the pH of the solution if 40 ml of the now solution is added. Okay, so yang ini panjang sikit calculation dia. So we're gonna use it. Okay, so number 2, still gonna use this one. Still gonna use this information. Based on this information, we only have 27.4. This time around, dia nak 40 ml pula. So, I'm just going to delete this one. It's not 27.4. Become 40 ml. Okay. So, how we going to find out the value? Macam mana nak cari? What will happen to the pH of the solution? Ni cerita dia panjang sikit. Macam yang ini. So, on your notes on page berapa ni? On page 17. Where you have to write down initial change final table dia kita nak tengok. Okay, equation ni make sure the correct one. Mole kita kena cari one by one. Okay, mole yang ini kena cari. Okay, minus what we have. Okay, panjang sikit tapi tak apa. Let us calculate together. Okay, so first what we're gonna do is write down the initial change final punya table. Okay, so I have my initial change final table. Okay, so what we're going to write down, okay, all the information from our SEM base lah. So we have my HA equals, added, reacted with NaO equals, we're going to form our NaE equals plus H2O. Okay, again, H2O liquid. Okay, we don't want any information. Minus, minus, minus. Okay, this one we're going to use the mole. We're not going to find out the molarity or anything. Okay. So, mole of our acid, actually kita dah cari di atas ni. 2.74 exponent negative 3. So, I'm just going to include this value. 2.74 exponent negative 3. Okay. So, if I use the previous one, sodium hydroxide boleh gunalah yang ni. Okay. Boleh ke? The question is. Okay. Sebab di sini, for our sodium hydroxide, the volume is when it is 27.4. Sekarang ni, we want sodium hydroxide, volume dia 40. Okay. So, we're going to find out the number of mole of NaO dululah. N equal to mv over 1000. Substitutekan the value from here. Okay, so here we will get 4 exponent negative 3 mole. Okay, so this one. Okay, only the acid we can take from the previous one sebab volume dia sama sahaja. 25 ml of acid, that is the fixed one. the fixed value that is present in the conical flask. So we can take this value. For the sodium hydroxide, we can't use it because the number of mole here is 127.4. Right now it's 40 mil. Okay, so we're going to substitute the value for exponent -3. Okay, our acid or our salt, okay, initially we don't have any product, so dia jadi 0. Okay. Change, we're going to take the smallest value present. So smallest value, we compare between these two, it's actually 2.74. So we're going to take 2.74 ni, kita akan minuskan lah all of this. Okay, the reactant will be minus, the product will be plus. Okay, again, since this is our reactant on my left hand side, yang ini kita akan tulis minus. This one will be plus. Okay, so for the concentration of our Na aqueous, it will be Na aqueous, our salt here, the value will be the same lah. Since 0 plus ni, this one you have to calculate yourself. Okay, the answer will be 1.26 exponent -3. This one will become 0. Okay, so what we have left is actually the now solution, the mole, this is 1.26 exponent -3. Okay, and our aqueous solution 2.74. Okay, next, what we're going to find out is actually the question asks for calculate the pH of the solution. Okay, so how do we find out the pH from here? Okay, back balik to our examples here. Okay, so contohnya kita dah dapat value ni kan. Okay, dah tahu dah value dia. Sekarang ni kita kena cari the new concentration. Okay, the new concentration. Molarity is equal to mole divided by volume. Tadi kita baru jumpa kita punya mole sahaja. Mole sudah. Volume kita tak tahu lagi lah. Yang ni, new concentration ni. Okay, new concentration of apa? What is left? Dalam our examples here, what we have is actually our sodium hydroxide. Sebab this one will be 0. Okay, so to find out the new concentration, I'm just gonna write down kat tepi ni lah. Okay, molarity of now is equal to mole divided by volume, which must be in liter. Okay, mole is 1.26 exponent -3. Okay, volume dia berapa pula? Okay, volume dia bukan 40. Yang ini adalah bila kita dah tambahkan. This volume is 65 mil, which is equivalent to 0.065 liter. Okay, so here 0.065. So the molarity will be 0.0194 molar. Okay. Yang ni panjang sikit cerita dia. Yang ini calculation ni. Okay. This one baru cari concentration dia. Okay, kenapa kita nak cari concentration? Because when we're talking about calculate the pH, pH is equal to negative log H plus. Kan? This is regarding concentration. Or we could also use POH is equal to negative log OH minus. So from this information, actually bukan dapat pH terus. Dapat POH dulu. Okay, so how to find out the POH? POH is equal to negative log OH minus, which is negative log 0.0194. Equivalent to, when we find out, is 1.71. Okay? Because we have our sodium hydroxide, Na plus OH minus. So we're going to find POH dulu lah. It's not pH. Okay? But then the question asks for the pH. Panjang cerita dia. So pH. So we're going to find out the pH. pH plus POH equal to 14. So here pH plus 1.71 equal to 14. pH will be 12.29. Okay, so that's the solution for question number 2. It's quite a long one. Usually kita cari molarity sahaja for the two previous years, 2020-2021 dengan 1920. Okay, the question usually ask for molarity only. This one, sampai sini saja. This one lagi lah equivalence point, the zero lah. This one is quite a long one. Sebab kita kena cari one by one. Okay, cari molarity dulu. Then we have to change the new concentration. Why? Because pH, dia adalah tentang concentration lah. Negative log H plus. Or kalau POH, negative log OH minus. So, kena cari concentration dulu. Okay. So, that is for question number 2. Okay. Nanti Miss buat time, you can look it again lah. Over the steps. And then I'm going to link as well the video for the calculation itself. Okay, next question, the last one. Explain qualitatively the pH of the solution at the equivalent point. So, explain qualitatively the pH of the solution of the equivalent point. Okay, ni pun soalan dia, consecutive 3 years. 3 years consecutively ada soalan ni. Ini pH of solution at the end point. Ini pasal KCN is not neutral salt using appropriate equation. KCN ni is actually our product lah. Ni pun pH solution yang product kita. Dia suka tanya pasal product. Okay. So, if they ask you about the product, it's actually the solution. It's actually about the product. Okay, which? Because we have NAA dalam case ni with the H2O. Okay. We will talking about the salt lah. We don't want to talk about the water. Okay, so yang ini pun sama juga, is actually regarding salt hydrolysis. Then how to do it? Okay, first kita tengok balik previously we have done. First we're gonna write down the salt. Okay, dissociate to form our ion. Okay, and then check whether which ion will form with water. Okay, sebab once we react it with water, we can see the product dia. Okay, ada apa? What does it have? OH minus ke? H plus. Okay, so I'm gonna answer question number 3 ni di atas ini pula. So, kita buat, our salt is actually NAA. So, NAA, again, it will be equals, dissociate to form our Na plus with our A minus. Okay. So, how do I know Na plus A minus ni? Sebab sodium hydroxide ni, this one, Na plus H minus. Ni, HA ni, H plus A minus. Okay. So, this one. Okay, and then we will react it with water. Again, sodium ni dia 2.8.1. Kalau Na plus, 2.8 sahaja. So, it's a stable ion. Already achieve voltage, it doesn't want to react. Okay. A minus ni pula, ni yang akan react kita. So, A minus ni kita mau react dengan apa? A minus equals ni, we will react it with water. H2O, liquid. Okay. So, what happened here? So, minus ni is actually our base. So, dia accept H plus. H2O ni acid. Dia donate H plus. So, what we have here, A ni akan jadi HA equals H2O jadi OH minus aqueous. Okay. And then, okay, soalan minta explain qualitatively the pH of the solution at equivalent point. So, adanya OH minus ni, okay, the same point as the previous example. So, kita bagi tahulah. Okay, OH minus shows that salt is basic with pH more than 7. Okay, again, why? Sebab pH less than 7 is acid. pH more than 7 is a base. So, macam ni lah. Okay, make sure. Okay, this one you have to write down. Sebab dia kata explain qualitatively, not only the equation. Bagi tahu juga. Sebab dia nak PH dia kan. So, tak boleh sampai sini saja. We have to tell that it is more than 7. Okay, so this video is quite a long one because the calculation for the question 2. Okay, so that's it, the video discussing the past year question 2018-19.